This lesson continues our study of functions, and in particular we're going to be looking at how you can define one function based on another. I really like this topic because it gives you really good practice using function notation and just using math notation in general. Okay, so suppose you have the function f of x, which is x squared minus 3. We're going to define another function, g of x, and it's based on f of x according to this equation right here. G of x is f of x plus 5. So what I'm going to show you how to do now is to find an expression for g of x. Well, g of x equals, well, what's f of x? I look up here, and in place of f of x, I write x squared minus 3, and then plus 5. And then it's just a matter of cleaning it up with algebra that you know. If you are subtracting 3 and then adding 5, that's a negative 3 and a positive 5. That makes x squared plus 2. So this is how you would write g of x without referring to f of x. Okay, let's look at another example. So we still start with the same function. F of x is still x squared minus 3. And our new function is g of f equals f of x plus 5. Now, that may look similar to the one I just did on the previous screen, but I'm going to flash back to that screen. So look at how it's slightly different. Notice in this one that the plus 5 is outside of the f of x, whereas in this one, the plus 5 is inside. Okay, that makes a big difference in how we work out this problem. So I'm going to now find a more explicit rule for g of x. Well, what do I need to do? I need to plug in x plus 5 for x in the f rule. Okay, this is kind of weird, but this is what you do. Instead of x squared, it's now x plus 5 squared, and then minus 3. So we're plugging in x plus 5 for x, okay? And then, again, it's algebra that you already know. We have practiced squaring binomials. So x plus 5 squared is x squared plus 10x plus 25. And then you still have your minus 3 out at the end. And as a final step, we can simplify it further by combining like terms. X squared plus 10x, the constants are like terms. 25 minus 3 is 22. Okay, so that's how you find g of x if the x plus 5 is inside the parentheses. Okay, next example. Starting with the same function, f of x is x squared minus 3. Okay, this time we are introducing a negative. So to find g of x explicitly, I'm going to take this negative and then I'm going to write the rule for f, x squared minus 3. Notice that I write it in parentheses because I need to take the opposite of the entire expression. Okay. The negative sign distributes across both terms inside the parentheses, so I get negative x squared, and then the minus 3 becomes a plus 3. And that's as far as you can go with that one. Okay, notice that the negative was outside the function rule. On this next example, we're going to start with the same parent function, but this time we're going to put a negative inside the parentheses. Okay, so the explicit rule for g of x would be, well, I'm going to take negative x, and everywhere I see an x, I'm going to replace it with negative x. So instead of x squared, it's negative x squared minus 3. Okay, and then, got to think about this one. If you take negative x times negative x, the negatives cancel out, and you just get x squared. So it turns out in this example, g of x is actually the same as f of x. Okay, and I'm going to write off to the side here. That's might be something you can think about a little more deeply. Why is it that negative x squared is equal to x squared? Well, it's kind of like this. Negative 3 squared is the same as 3 squared. And it works for any number. Negative 5 squared is the same as positive 5 squared. So negative x squared is the same as x squared. Okay, so for homework, I've given you 4 different functions and asked you to find an explicit rule for a new function based on the f of x function. Okay, good luck. We'll go over it